Good afternoon, everybody. Fergus Dolan here from NALA. Delighted to have you here today for our numeracy webinar on fun and practical approach to teaching geometry. It's part of our Maths Week webinars. We've got webinars on every day on numeracy. So we're delighted to have Tony Sweeney here today facilitating. Tony's an experienced maths trainer and tutor from, he worked with Galway ETB. So over to you, Tony, and all the best.
All right, thanks, Fergus. Hello, everybody. Welcome to Maths Webinar Week. My name is Tony Sweeney, as Fergus said. The subject today is geometry. Just before we get started into the main business, I'll just say a few words about the program. In total, there are 13 modules in today's presentation. The webinar introduces several teaching approaches that you may like to try. Most modules have a number of geometric tasks. There is a strong emphasis on visual and animation mediums with the minimum of text used. So I will mix the academic modules with some fun items and practical approaches to use in geometry. By the way, you are free to use any of these slides. Most are suitable for the QQI level 3 maths. Okay, let's look at the first module. So this is a little introduction, Matchstick min and squares, I call it. So using two more squares, put each matchstick man in his own space. So it could go like solution here, like this, and like this. Now, the idea of something like this is so that students will participate and they will experiment. So the idea is that they would draw the images and that they would put in the squares at random. And it's to create a positive atmosphere in the classroom. Very important. So the second module is drawing an envelope. So draw an envelope with a pen without crossing any lines or taking your pen off the page. Goes like this. And I'm sure you've seen this before, but this is not where the focus is really. Now, so there. That's a fairly complicated maneuver. So we're going to find something to simplify that. So here we go with a drawing aid and with an arrow, of course, as well. Now you can see that this complicated maneuver over here has been made very simple just with a drawing aid. And students should be encouraged to make their own kind of mark or drawing aid with any geometric problem. So it doesn't have to be well drawn, just a rough outline. So module 3, making squares with matches. And this little problem is you have 4 squares here, but you have to reduce that down to 3 squares. And you move 3 matches and leave 3 squares of equal size, right? So let's see how this goes. The solution. Now, the benefit of doing something like this is that you, on the one graphic, you have the start situation here, and you have the final situation. So you have the two of them on the one graphic, because sometimes students kind of, when they start off, they lose track and they say, oh, where did I start out from? So the beginning and the end of a problem, they get kind of disassociated, if you like. Now, that's example 1. I'll do the second example now. So here goes. And just a bit like the last example, if students might want to look at the pattern. So there's two matches from this square and there's one from this one. It's a bit like, if I go back to the last one, you have it there. You have two matches here and one from here. I'll go forward again. And there you have it. Two from this square and one from there. So you can see there's a pattern to these moves. That now, that's useful for students because later on, they may have to find patterns of angles and lines in order to solve geometric problems. Now, module 4, I call this lines and angles. It says draw an angle of 40 degrees. So you have a line, and you have a line there, okay, and you put down your protractor. Now, you have to measure 40 degrees, and sometimes for students, they make a mistake because they use the wrong layer of degrees written on the protractor. So instead of taking 40 degrees here, they may take 40 degrees over on this side, right? So when you're going from this line, you'll take it 40 degrees here. So they have to be, this has to be pointed out to students. So that's it. Now, related to that, I have this thing called estimating angles. So estimate the size of the angle. The student has a go at it. Now, we know that that angle is less than 90 and that it's probably greater than 50 degrees. So here we put up the protractor on it and we find out that it's 70. Now, the fact that students can estimate an angle, it means that they're saved from making huge mistakes. So that's the benefit of that. So 70 degrees. Now, looking at it from an alternative view, if you look at an angle of 140, a student might like this better. So something like that, 140 degrees. Okay. Now, I thought that I'd introduce something here to bring geometry outside the classroom. So this is snooper table angles. So here you have it. This is a very easy shot to start off with. Okay. Now it's a bit more complicated. Everything does, you know. So you have two angles of 45 degrees and you have 90-degree angles here. So this is a line to say where the ball is supposed to go. Okay, and we have to pot that one. So here it goes. Okay, we'll try another one. This time we'll do angles of 60 and 30 and of course the right angle 90 degrees. Now, we are going to put the red one in off the other red one. Good shot. I like it when it works out. Now, this is a Ronnie O'Sullivan shot, right? Here it goes. Now, this is tying into the estimation of angles. We don't really know what these angles are, but we're trying to have the same angles in these places. There and there and there and there and there. So here it goes. This worked last night, so it should. Yeah, great, fantastic. Okay, so that's the estimation of angles where it's useful and bringing it out to the classroom.
Tony, I'll just interrupt you for a sec. Bridie McLaughlin's asking what software you use to demonstrate that.
This PowerPoint.
Okay.
Just PowerPoint. It took me a long time to create these, but, okay. But I enjoy doing it. You know, it's PowerPoint, okay. Microsoft PowerPoint, and it's 2016. Yeah. This is module 5, rules for triangles. So these are also called theorems. And the first one, a very important one, is the three angles of a triangle add up to 180 degrees. So I make a copy of that triangle and I get this one and I turn it upside down. So you can see the three angles together there make up 180. 180 degrees is for the straight angle. So you can see the three angles make up 180. It's a visual to help students. So angle B plus angle C plus angle A is equal to 180. Now, the exterior angle here is equal to these two. So this is a kind of follow on from the last one. So we have, this is A plus C here, and it's equal to, of course, to A plus C here. Okay. An isosceles triangle. Now, when you have two lines equal, the angles at the base are also equal. So here you go. So we have a problem, just set a problem here. They're called problems in algebra, of course, but find angle A. So, and don't say, look at it there. You know, so one of my students cracked a joke one day on this. This is 40 degrees, right? So here we take it from 180. This is teacher work calculation, and this is more teacher work, and this is the answer. Okay, I won't bore you by going through the divisions and subtractions. This is an isosceles triangle looked at from a different perspective, because sometimes when students are faced with something that's unfamiliar, they don't recognize it when it's in a different position. An equilateral triangle, find angle A again. So here it is. So this is teacher work to divide by 3, and there's angle A. Okay. A scalene triangle. All sides are different lengths, and all angles are different sizes. So that's all I have to say about that one. A right angle triangle to do with 90 degrees, and we're explicit here. We make sure that students often get confused with that, the hypotenuse, where the hypotenuse is. Now, and sometimes when it's from a different perspective, it's even more confusing. So there it is. Now, this is the problem to do with putting two of the rules that we learned, put them together to solve a problem, and to manipulate the drawing as well. So we know that that straight angle is 180 degrees, and okay, so that's a teacher thing. So 130 degrees, and so okay, this I'm just clicking off that person. There, so we know that that's an isosceles triangle, and that's another one. So the problem when you have manipulated the diagram, it's easy to solve this now. So this is the three angles together equal 180, and you take 130 from each. That's teacher work, and here, and you find that angle A is equal to 25 degrees. And the other one is similar, where you have angle C and D plus 50 equals to 180. And this is just take 50 from each side, and you find that, and then you have a D equal to 65, right? 65 degrees. Now, my screen has gone a bit strange here, but it's okay. I'll persevere. Constructing 4 triangles, right? So the first one here is this, and we put up a drawing aid. It's the easiest way to follow this rather than just reading all this out here. So the drawing aid, this one has a line of 8 centimeters and a line of 6 centimeters and 50-degree angle included. So we draw the line, here, and that's 8 centimeters. We get our protractor and we draw an angle, this angle here of 50 degrees, right? And we just draw a line as long as we want, really. Now we get the ruler and we measure 6 centimeters for this line here. And we cut the line, okay, 6 centimeters, and then we just join up. And that's it. That's our first triangle. Our second triangle is this. This is drawing aid for it. We have 2 angles, one of 50 degrees, the other 40 degrees, and 8 centimeters of a line. So we draw the line first, 8 centimeters. So the first angle is 50 degrees, right? 50 degrees here. And then we go over, we draw the line, right? And then we go and we get this 40-degree angle on this side. So we measured from the other side now, when it's going from north up. So we just draw that, and there it is. This angle, that's triangle 2. Triangle 3 is, I really like this one. I've always liked it. You have a line of 8 centimeters, 6 centimeters, and 5 centimeters. So you draw the 8 centimeter one at the bottom. You get 6 centimeters for this line, and you just make an arc there. You measure 5 centimeters for this side, and you draw an arc from that side. Okay. Now you get your ruler and you just join the line up to where the arcs intersect. That's it. Perfect. Looking good. Now, this triangle, you have to draw a line of 4 centimeters, an angle of 90 degrees, and a hypotenuse of 5 centimeters. So the line goes there, the 4 centimeters. Draw that. We draw an angle of 90 degrees, right? And now we get 5 centimeters for the hypotenuse. And we just put the compass there, draw it, and just connect up. There it is. That's the 4th triangle. Now, the last construction we're going to do, we have to draw a square with sides 4 centimeters. This is on QQI level 3 as well. So there's the drawing aid. So we start off with a 4 centimeters line. We get our compass, or our protractor, sorry, and we measure 90 degrees and draw a line. On the other side, we do the same thing, a 90-degree angle, and draw a line. The line can be as long as you want. Now we get our ruler and we measure 4 centimeters, and we cut 4 centimeters off there and also there. And then we get our ruler and we just close it off, and there we have our square. Okay, now at this point, you've gone through a good lot of intensive mathematics, and doing this with students is it's not a good idea, doing all this together. So I'm introducing something now that I've always done in class. I always break the students' concentration and let them relax by maybe telling a joke or doing a clip from YouTube or something like, you know, Father Ted or whatever, or maybe Mr. Bean or Faulty Towers, just short little clip. And this is based on a joke by Brendan Grace, one of my favorite comedian, and so I'll let it run. So you have off the west coast of Ireland, 2A and 2A. You have 2 lights in the sea. Hey, what in the name of heavens is that? Attention, attention, this is the Irish Coast Guard Service. We request that you change course by 15 degrees to the north. Hello, this is the SS Lincoln of the American Navy Fleet. We request that you change your course by 15 degrees to the south. Imminent danger. This is the Irish Coast Guard Towers. We request that you change course by 15 degrees to the north, or you will be in imminent danger of collision. Oh, this is the SS Lincoln of the American Navy fleet. We are the biggest and most powerful aircraft carrier in the American Navy. We don't change course for anyone. We are telling you to change course by 15 degrees to the south or face immediate action. Oh, you look really impressive. Move out of our path because we're coming straight through. All right, so please yourself, but be careful because we are at the lighthouse. Okay, now I can't hear you laugh. Okay, so yeah, every person that tells a joke needs a feedback of laughter. Anyway, okay, so let's move on. Now, when the clip is over, you go back to the lesson that you're teaching, so that they have a chance to recall what they were learning. Now, you don't go back to it in an examination kind of way. You go back to it in a cooperative manner. So where you solve the problem with the students together, and it helps them recall. They can recall it in comfort, where if they go wrong, they're helped. So these are some terms that are used in QQI, bisecting an angle, right? So you set the compass at a certain length. Now you can change it at this one if you want, but you have to maintain it then for this one. So this is very simple. So you just join it up, and there you've cut the angle in half. Okay. Now this is bisecting a line segment. So this, you make sure that the compass is the width of the compass should be greater than half the line. So you put an arc there, and down below it another one, and over here another one, and here another one where it intersects, and just join them with the line. So the line is cut in half. And there, these are also 90-degree angles, and that is a perpendicular line. Okay. So parallel lines, just a small explanation for them. When they have the arrows, it means they're parallel. Poor joke about this is that parallel lines could be right beside one another, but they're very strange. They never meet. Okay. Anyway, so equal length. These lines are equal. They're the same distance apart all the way. Circles, right? In module 9. So we're going to draw a circle with a radius of 4 centimeters, and it goes like this. Now, in the past, when I used to have to draw circles on the whiteboard, and not very well, I must say, I got a comment from a student once said, "Oh, lovely potato, Tony," you know. Anyway, so here goes. So you find the center of the circle. So we draw a chord, and we draw another chord. It doesn't matter where, really. But we bisect that line, that chord. Okay, and we join up where it intersects. We bisect this line. We join it up. Okay, and the center of our circle is there, where they meet. Okay, now this is triangulation, intersecting lines. I was a fisherman for about 20 years, and I learned this from a crew member. Very useful bit of knowledge. So this boatman, he has found a dangerous rock. Now I can't see the top of the screen, unfortunately. He needs to go ashore to get a buoy to mark the spot. How will he find the rock again? So we go to solution, and he picks 2 points. He picks points. By the way, this is Ballycroy, County Mayo, beautiful part of the world. This pole, he lines it up with the top of this peak, which is Nathanbeg. And he looks in the other direction, south, and he lines up this pole with the shed on the top of that hill. Now, this is the only place that these two lines can intersect. So they intersect here where the rock is. Now he goes and gets his boy and he plants it there. He knows, he comes out, and when he has aligned the two objects here and the two objects here, he knows this is the spot. So it's all safe. Here I go with my new boat. Looking good. Okay. So I think we're just on time. Time's okay. Now this is a scale drawing. It's module 11. So this is a house plan, and these rulers are down as scale. So the scale is 1 centimeter equals to 1 meter, or if you want it in ratio, that's 1 as to 100. So this is drawing the house. I'll do it very quickly. And this is a quick built house, I'd say. It's a bad joke, is it? Anyway, that's your house plan. Calculate the floor area of the house. So solution, it's 10 meters long and it's 7 meters wide. So that gives you an area of 70 meters squared. Okay. Now we move on to module 12. And this is Pythagoras Theorem. And first we start off with a visualization of what it means. So here we have this, the 4 centimeter line. So we square that. So that's 16 centimeters squared. And we square this one, which 3 by 3 is 9 centimeters squared. And that's equal to 25 centimeters squared. 5 multiplied by 5 is 25 centimeters squared. So that's visualization of it. Now we can move on to looking at where it's used most often, where we have to find one of the lines of a triangle, of a right angle triangle, I should say. So here we have, again, 4 by 4 is 16 centimeters squared, plus 3 by 3, 9 centimeters squared, equal to. Now we have to figure out what it's equal to. So we know if we add 16 and 9, that's 25. So that's 25 centimeters squared. Now, in order to get this line, we have to work backwards. We have to get the square root of that number in order to find this line. So here it is. The square root of 25 is 5. 5 centimeters, okay? 5 centimeters multiplied by 5 centimeters is 25 centimeters squared. Okay, now, this is another view of the theorem of Pythagoras. And you can frame your teaching of this in this way if you wish. It's taking all the academic language out of this problem. And okay, it's field development. This is a GAA field. And 2 guys are given the task of marking the field. And they talk in ordinary language, how it's done. So one guy says, how are we going to get those corners squared off when we are marking the field? I think that we will have to consult Pythagoras. I just moved that up to the top. Yeah. So, what do you mean? he said, if you measure 4 centimeters from A to B, 4 centimeters from A to B, then, and next you measure 3 centimeters from A to C here. Then if you get a distance of 5 meters between C and B, that will give you a 90-degree angle there. Okay. So I'll do that again. That's from A to B 4 meters, and from A to C 3 meters. And then if it's 5 meters there, then that will give you a 90-degree angle there. So who is this Pythagoras guy anyway? A very old Greek guy. You hang out with strange people. Indeed, yes, I suppose that I do. How do we go about drawing it on the field? And if you get a loop of string, it should be, let me see, 12 meters long, because 3 meters plus 4 meters plus 5 meters is equal to 12 meters. The first marking on the field will be a sideline. Start at A here and put down the marking in a straight line towards B, and continue on until it is 140 meters long. That will be the length of the field. Make sure that the distance between A and B is 4 meters. Okay, I'll do the hard work. You can stand there and pretend you're the boss. Now, you put a peg in the ground at A, here, and put another one in the ground at B, here. Hold a third peg in your hand, this one. Okay, I get it. Put a mark at the knot on the string. This will be matched with peg A. So then the mark here will be matched with peg A. Measure 4 meters from the knot and put a mark there. This will be matched with peg B. So here, peg B will be this mark. Go to the knot again, measure 3 meters in the opposite direction and put another mark on the string. This will be matched with the peg in your hand. So this one here, so this mark here will be marked with the peg in your hand, matched with it. Okay, marking is done. What's next? Put the loop of string around pegs A and B, like there. Match the marks for A and B on the string with the pegs in the ground, right? Put the peg in your hand into the loop, this one here, into the loop, and match it with the remaining mark, with this one. Okay, that's easy enough. Pull the loop using the peg in your hand in the general direction of C until it is tight, here, right? Push the peg into the ground. Now you will have a 90-degree angle at A. Got it. Now mark the line from A to C, and continue until you get a distance of 80 meters. That will be the width of the field along the end line. I suppose that I'll have to do that too. To make it easier to get straight lines, you can use bigger measurements. You don't have to use 3 and 4 and 5. You can use 6 and 8 and 10, for example. I prefer to use 30 and 40 and 50. That's a lot of string. Maybe we should just look at the angle and guess it. It's much quicker and less work. Now you will have to do the same thing at 2 more corners. You can continue at the end of either the sideline or the end line. Now I remember doing the theorem of Pythagoras at school. I think that what we did there was called the inverse of the theorem of Pythagoras. I liked maths, you know. So you knew this all along. Well, yes, but you helped my memory. You were good. You should be a teacher. Now, this is the last module. So, and we're comparing circles, squares, and triangles. And you know, if you feel you can do it, you can frame it in the following way, if you wish. Right. I think my square is bigger than your circle. What do you mean by bigger? I mean bigger area. Look, indeed it is not. Just look at them, for heaven's sake. Let's compare them so. Okay, now we'll see. Well, what do you think? Jeepers, I don't know. I think that my square is bigger. Look how it goes out further at the corners. Yours has no corners at all. Not at all. My circle is taller and wider than your square. Ha, it's just my luck. Albert is on Zoom today. Do you guys need a hand? Maybe, yeah, I think so. Right, okay. First, we have to carry out a few measurements. A side of the square is 5 centimeters. All sides of a square are equal. The area of the square is 5 centimeters multiplied by 5 centimeters is 25 centimeters squared. Now we must get the area of the circle. To get the area of the circle, we first must get the length of the diameter. The length of the diameter is 6 centimeters. Next, we get half the diameter. This gives us 3 centimeters. By the way, this is called the radius. Next, we make a square with sides the length of the radius. Here it is. So the area of the square is 3 centimeters by 3 centimeters equal to 9 centimeters squared. This is called the radius squared. Next, we need the help of a person who lived a long time ago in Greece. His name was Archimedes. He found out that you could get the area of a circle if you multiplied the radius squared by 3.14. So the area of the circle is 9 centimeters squared multiplied by 3.14 is equal to 28.26 centimeters squared. There it is. So there you have it. The circle is bigger in area than the square. Indeed, it's hard to believe it, but I take your word for it. Now that I have you here, could I ask you which is the bigger, the triangle or the circle? Measure the length of the base of the triangle. The base of the triangle is 10 centimeters long. Now get half of that distance. That is 5 centimeters. Measure the perpendicular height of the triangle. Perpendicular height of the triangle is 6 centimeters. Now multiply 6 centimeters by 5 centimeters. That's 30 centimeters squared. Thanks for your help. I suppose that these problems are relatively easy for you. Generally, I welcome them. I don't know how that joke went down with Albert, but just look at his face. Okay, he's not happy. Okay. Now, this is another view of Betty Croy for you. Thank you for your attention. My email is there if you want to contact me, towini@gmail.com. Thank you very much.
Tony, thanks a million. That was great. Really interesting. It's tough delivering the jokes when you're not in the room with the people and everyone's on mute. So
especially when they're not very good.
some of them were good. Sometimes the joke is so bad that it's good.
Yeah, I try.
Absolutely. We've got 15 minutes left. Has anyone any questions? Because we have a small number of people, 11, I suggest you unmute yourself and just ask Tony if you have a question.
But see, can I unmute? Yeah.
Will you unmute? No, you muted yourself, Tony. You unmute yourself again. You're muted now, Tony. Tony, we can't hear you. You didn't need to do anything there. You were.
Oh, did I not?
Yeah.
Okay, so yeah, right.
So if anyone has a question for Tony, if you could just unmute themselves now and ask. As I said, I will be sending on his presentation after this. I'll email it on to everyone. So if any of you were a little bit late joining, you can receive it all. So if we've no questions, we might as well leave it there, Tony. Yeah.
That's okay.
Thanks, Tony. That was great. Yeah. I've no question, but it was a great presentation. Thank you.
Oh, thank you very much. Thank you. Yeah,
Thanks,
I always like the praise, you know, even at my age. But if you think of any questions, maybe in the following days, you can email them to me. You got my email address there, you know, and I'll do my best, you know.
Maybe you could do another presentation of how to actually do the slides.
How to what?
How to actually, you know, show your snooker table and all that. How you did all that.
Oh, it was a long process. Like it's only putting pieces together. I think there, you know, in the pool table there must be 50 or 60 pieces.
Yeah.
You know, but this is my hobby. I love this. You know.
Very good.
Very good. Very good.
There, Tony, Joan Hickson says great jokes too.
Sorry.
If you like them.
Who has?
Joan Hickson. She typed into the chat box. Great jokes. Thanks, Tony, and great.
Oh,
jokes.
I see. Yeah. All right.
Yeah.
Okay.
So
thanks.
the maths people like the jokes.
Yeah.
Okay. Well, listen. Thanks very much to Tony for a great presentation, and you can see that he put a lot of work into those slides, into creating the snooker table and the other things. So we really appreciate that, Tony. And as I say, I will send on his presentation to all of you after. And thanks everyone for joining in. I hope you learned something and got some ideas for the class for teaching geometry yourselves. So I'll say goodbye to everyone, and thanks again, Tony.
Yeah. Right. Thank you. Thank you.
Thanks.
Right, bye.
Thanks a lot.
All right.
Bye.
Thank you.
Bye.